हेलो स्टूडेंट्स। आज स्टार्ट कर रहे हैं हम फर्स्ट चैप्टर इलेक्ट्रोस्टैटिक्स। इलेक्ट्रोस्टैटिक्स को हम दो वर्ड्स में ब्रेक कर देते हैं, इलेक्ट्रॉन प्लस स्टैटिक्स। इलेक्ट्रॉन्स मीन्स चार्ज पार्टिकल, static means rest. It means charge particle at rest. In electrostatic, we will study about the charge particle at rest. Further, charge can be break into two categories or two types: positive charge and negative charge. Positive charge basically represented by proton, which have plus 1.6 into 10 to the power minus 19 coulomb, and negative charge represented by electron, which have minus 1.6 into 10 to the power minus 19 coulomb, where the coulomb is the unit of charge. Now we will forward into the important property of charge. There are some important property of charge. First, like charges repel to each other, and unlike charge attract to each other. And second property, charge obey the law of conservation. You know very well what is the conservation. Conservation means you cannot create or destroy it. It means charge cannot be created, cannot be destroyed. It means total charge all over the universe is constant. Next one, charge follow the additive law of number addition. It means जिस तरीके से हम सिंपल नंबर्स को ऐड कर देते हैं, if we have the any numbers minus 2 plus 3 plus 4, the total sum of the number is minus 2 plus 3 plus 4 equal to 5 plus 5. Similarly, if we have the different charges minus 3 coulomb, 4 coulomb and minus 6 coulomb, the total charge Q is equal to minus 3 plus 4 minus 6 equal to minus 5. Clear? And last and important property of charge is quantization of charge. What is the meaning of quantization? Quantization means any quantity represent in some specific number multiple. Similarly, the charge is always exist in the integer multiple of electron, where the n is integer number, just like 1, 2, 3, 4, 5 up to infinity. And the E is the charge on electron. And the value of charge on electron minus 1.6 into 10 to the power minus 19 Coulomb. Clear? Now deeply explain the quantization of charge. We know the quantization Q is equal to plus minus NE is a condition. Condition of quantization. Condition of quantization. What is the meaning of condition? If we have the Q is equal to plus charge, a positive charge, it means there is lack of electron or shifting of electron. Further, Q is equal to negative, it means excess of electron or presence of electron. By this formula, we also find out the how many electrons shift or transfer. So according to the formula, if we have the given charge 1 coulomb and question is arise how many electrons present or shifting in 1 coulomb charge plus 1 coulomb charge, Q is equal to plus minus Ne. N is equal to, we have the plus charge plus Q upon E. Plus Q is 1 coulomb and E is the charge on electron is 1.6 into 10 to the power minus 19. Because we have already said that the positive charge, it means lack of electron. How many electron? We calculate about this. This value give the frictional number. This value give the frictional number, but with the whole by the method of the round of number, we find out the particular specific numbers, that is known as the lack of electron. If there is a minus 1 coulomb, it means the excess of electron. Clear? But there is an exception. It is out of syllabus, but for the information I will tell you. Quark. What is a quark? Basically, quarks is just like electron particles, but electron exists in the stable state or free state, but the quarks does not exist in the free state. And the quarks have the charge plus minus 1 by 3 and 2 by 3 coulomb. All the quarks in free state, by the combination It forms the neutron, proton and electron. So that's why we don't discuss about this charge, frictional charge in quantization. Clear? Next, we come to the point, Coulombs law. Coulombs law. What is a Coulombs law? According to the scientist Coulomb, we discuss about the charged particles exist, experience a force to each other, between each other. According to Coulomb's law, it considers a two charged particle Q1 and Q2. Its limitation of the Coulomb's law, that's it only work between the 2 point charges. Clear? If two charged particles Q1 and Q2 are placed separate by distance r between the two charged particles, a force is experienced. It may be attractive or repulsive. It depends on the polarity of the charges. What is the polarity? Polarity means sign convention. It is positive or negative. It is the polarity. According to the Coulomb's law, if the two charged particles are separated at r distance, the force experienced between the two charged particles depend magnitude depends directly proportional to the magnitude of charges and inversely proportional to the square of the separation between them. If we combine both the equation, so F is proportional to Q1 Q2 R square. If we remove the proportionality constant, there is a constant which is known as proportionality constant. And the value of proportionality constant K is 1 upon 4 pi epsilon naught. And the numerical value 9 into 10 to the power 9. And unit of the proportionality constant is Newton meter square upon Coulomb square. It is also known as dielectric constant. There is a new term epsilon naught. It's not known as epsilon naught. Epsilon naught, known as permittivity of free space. Permittivity of free space. The value of permittivity of free space is 8.85 into 10 to the power minus 12. And the unit is inverse. Unit is the inverse of dielectric constant. C square and Newton meter square. Clear? If this permittivity explained for any medium, it is known as epsilon. Clear? If permittivity represented like this, it means epsilon upon epsilon naught. Relative permittivity of medium. Clear? So if we replace the medium by any other medium, then the epsilon naught will be changed, maybe epsilon naught, epsilon or epsilon r, ठीक, according to the medium. नाउ चेक करते हैं हम कि इस परमिटिविटी से इस फोर्स पर क्या इफेक्ट पड़ता है। अगर हम डिपेंडेंसी फैक्टर देखें, डिपेंडिंग फैक्टर जो इस फोर्स को, जो चार्ज पार्टिकल्स के बीच को इफेक्ट करते हैं, तो अकॉर्डिंग टू फॉर्मूला, अगर आप ध्यान से देखें, ये आपको फॉर्मूला दिखाई दे रहा है यहाँ पर। अगर हम फॉर्मूले पर देखें तो हमने यहाँ पर फॉर्मूला लिखा है कि F इक्वल टू 1/4 बाई एप्सिलॉन नॉट Q1 Q2 अपॉन R स्क्वायर। तो यहां पर डिपेंडिंग फैक्टर्स क्या होंगे? कूलॉम फोर्स के डिपेंडिंग फैक्टर्स क्या होंगे? फर्स्ट डिपेंडिंग फैक्टर्स है मैग्नीट्यूड ऑफ चार्ज, क्योंकि हम रिप्रेजेंट कर चुके हैं कि डायरेक्टली होगा, क्लियर। दूसरा डिपेंडिंग फैक्टर है आपका सेपरेशन बिटवीन दैम, क्लियर। और तीसरा जो फैक्टर है, जो यहां से आपको ऑब्जर्व नहीं हो रहा है, बट हम जब डाइलेक्ट्रिक कांस्टेंट को एक्सप्लेन करते हैं तो तब हमें पता चलता है कि इसमें एक टर्म आई है एप्सिलॉन नॉट, जो मीडियम को इफेक्ट करती है। तो थर्ड कंपोनेंट जो है, ये थर्ड फैक्टर जो है, परमिटिविटी ऑफ फ्री स्पेस, क्लियर। तो इंपॉर्टेंट बात ये हुई कि परमिटिविटी को हम कैसे एक्सप्लेन करते हैं और क्या इफेक्ट इस कूलॉम्स लॉ पे पड़ता है। चलिए आगे हम बात करेंगे व्हाट इज द इफेक्ट ऑफ परमिटिविटी ऑन कूलॉम्स लॉ।